There. Today we're going to talk about problem number 2 in the challenge problems. That's the back side of the challenge problems. On the front of the challenge problems, the first one, where we have Matt the window washer. For that problem, I just want to advise you to consider the mass of both Matt and the platform and make a free body diagram just showing all the forces involved there. I mean, all the forces. That should help you work your way through it. It's not a difficult problem. It's just figuring out where the forces are going, what's being pulled, and in which direction. Okay, you should be able to figure that out. Think of the elevator problems. It's very similar to that. Sum up all the forces, and it should equal that acceleration there. If you're desperate for an answer for that, you can always email me, and I'll help you out there. So let's do number 2, the second problem. This problem says blocks 1 and 2 are accelerating to the right. So that means that we have an overall force going this way, going to the right. Force 1 is pointing to the right, and force 2 is pointing to the left. There's a contact force. We'll call it N between the blocks. Which statement is true? So there's a contact force here. Oh, whoa. Contact force there that we'll call N. Right. What's this? What's going on here? I don't want this. Give me black. And here. What is? Get out of here. Oh, I had it upside down. Okay, never mind. I had the eraser. Right. Back on track. So the best way to figure this out is to think about each block kind of individually. We know that the whole system's going to the right. And if we consider just this first block, I'll call that block number 1, and this one's block number 2, then things can start making a little bit more sense. So let's go through this. Block number 1 is supposed to be a block, has a force going on it in the right direction. I'll just redraw that real quick. Force going this way. And whatever force is opposing that force, the force is going to be a contact force between 2 and 1. So it's going to be a force pushing back on 1. So we know that I'll label that green. That's going to be a contact force of this block. It's going to be a force pointing this direction here. Whatever that force is, it's not going to be as much. What is this? I call this N. It's not going to be as much as F1 because it's accelerating to the right. That means that this force is greater than this force, and it's greater than this contact force here between 2 and 1. Because if it weren't greater, if the F1 was not greater, it would not be going to the right. It would either just be staying still, if it would equal it completely, or it would be going to the left. But it's not doing that, so it must be going to the right. That means that F1 must be greater than N. So I'm just going to write that down. We've got F1 must be greater than N. Okay, now let's consider the second block here for the second part of this. We want to think about force number 2 and block number 2. So I'm going to redraw block number 2 right here. And this is the explanation for B. So I'm kind of going to problem B and then solving it and then choosing a choice in part A. So you're going to get both of these answers for number 2 and just as one explanation. It's pretty easy. So here we go. Let's take a look at that block number 2. I'm just going to draw it over here, just separate from block number 1 so we can separate it in our minds too. So this is block number 2, and we've got the force number 2 on that. Force number 2 is going this way. That way. Good. Right. And then the contact force between 1 and 2. 1 is going to be, the contact force is going to be opposing block number 2. But think about this. If you've got these two forces going at each other, and the whole system is moving to the right, what must this force be? in relation to F2. Would it be greater than F2? Would it be equal to F2? Or would this this contact force right here, I'm going to just call it N. Would that force, I'll just call it, yeah, N's fine. It's a force though. Would that force be greater than F2? Less than F2? Or equal to F2? Well, if it was equal to F2, nothing would move, and that's not true. If it was less than F2, so if this force right here was less than F2, that would mean that F2 would be greater than it, and if you sum up all the forces on 2, that means that the force will be pointing in the left direction, and it's not going left, it's going right. So that must mean that the N is greater than F2. So we know that N is greater than F2. Whoa. Greater than F2. So that's all this whole problem is. You just break it up into two sections here. N, which is the contact force opposing this force right here when you're pushing these blocks, is less than F1 because this is going to the right. And here it's going to the right, so N must be greater than this opposing force over here, F2, whatever that is. So overall, you're going to get F1 is greater than N, and N is greater than F2. So if I write out everything, I'll just write F2 first since I'm in blue. It's going to be F2 is less than N, which is less than F1. And that is choice, what is that? Choice 4, looks like. Choice, that's Roman numeral, IV. IV. And I've outlined the reasons why. Simply because everything is moving to the right. It's moving right there, it's moving right here. And you can explain there that if it was equal, if the forces were equal here, there would be no movement. They'd be canceling each other out. But since F1 is, since there is movement here, there's F1 is greater than N, and over here, since there's movement to the right, N is greater than F2. So that's the way you can kind of reason through this. It gets a little bit tricky when you're thinking about the contact force kind of pushing this way and pushing this way. Especially when you've got two different forces pushing on different directions. You might be thinking, okay, this must be equal and opposite force right here. Opposing this, that's not true. The whole system's going to the right. So break this up into two separate problems and think about it that way. That'll get you going in the right direction. Okay, anyway, that's the full explanation. Let me know if you have any questions about this, and good luck solving the first problem. Should be pretty easy. It's easier conceptually than this is, so just consider all the tensions and so forth, and you'll be fine. Okay, good luck. See you Monday.